Push that rock with Simpson math. Let's take derivative by power rule and look at tangent lines. What is the derivative of this function here? Well, this is a rational function. We don't have a rule yet for it. We'll get a rule for rational functions later, but we can turn this quite easily into a polynomial. We will decompose the fractions, as mathematicians say, or walk like an Egyptian, as I say. I call this decomposition of the fraction when you have a polynomial in the numerator and a monomial in the denominator. You can break it up in this way. I call this walking like an Egyptian. So we can do that, and then we see that we can reduce. So I'm going to reduce this to x cubed minus x squared, and then I have plus 3. And now we're going to take the derivative of this. So to take the derivative of this, we're just going to go term by term, and we can do that because derivatives are linear. So we can take the derivative of this, and then take the derivative of this and put a minus in between, then take the derivative of this and put a plus in between. And here we use the power rule. You bring the power out front and subtract 1 from the power. Bring the power out front, so put the 2 out front and then subtract 1. And now the derivative of 3. What's the derivative of 3? Well, 3 is just a constant. It's just a flat line. What's the slope of this flat line? That's right. The slope of this flat line is 0. So when I take the derivative of 3, I don't get anything back out. Here is the derivative. Now, technicality, notice that 0 is not in the derivative of the original function. You could put 0 in here and get out 0, but 0 is not in the derivative of the original function, so you would not use this derivative to map 0 if you're trying to get the slope of this, because this function is discontinuous at 0 and therefore doesn't have a slope at 0. That's a technicality. Okay, let's do another example. So let's answer this question. What line is tangent to this curve when x is 32? Well, we got to know what a tangent line is. A tangent line touches the curve at a key point, at a key x value. So it shares a point, but it touches it in such a way that it also has the same slope as the curve. So it shares the slope with the curve. That's a big deal. So when we try to get a tangent line, we have to find the shared point and the shared slope, and then we just find the equation on the line. So those are the steps, okay? Those are the steps right there. Let's walk through them. So I need the shared point. Well, I just evaluate the function at the given x value. So I'm taking the 5th root of 32, and of course I get 2. So when you put in 32, you get out 2, and that is the xy shared point. This point is on the curve, the 5th root curve. It's also on the tangent line. Okay, so we found the shared point. We need the shared slope. Well, how do you get the slope of the curve? You take the derivative, okay? So I rewrote this 5th root as x to the 1/5. So I could do the power rule, 1/5 times x to the subtract 1 from 1/5. Okay, 1/5 minus 1 is the same as subtracting 5/5. So when I go 1/5 minus 5/5, I get a negative 4/5. So that means the derivative is equal to, this negative puts it down in the denominator with the 5. This denominator is the root, so it's the 5th root, and then we have the power is 4, and I could put the 4 under here or out here, either way. So there is the derivative, but we want to know the slope, so we will put at 32, so we will put 32 in here. So the slope is going to be 1 over 5 times the 5th root of 32. The 5th root of 32, the 5th root of 32 is 2. So we get the 5th root of 32, and then we're going to raise it to the 4th power. But this is a 2. And we raise it to the 4th power, so we get 16. So we have 1 over 5 times 16, which, of course, that means it's 1/80th. So have we found what we needed to get? Let's go back to our original statement. We said we would need a shared point. We put in 32, got out 2. We said we'd need the shared slope. It's 1 over 80. Can we get the equation of the line? Well, the equation of the line is y equals mx plus b. And we have an m, it's 1 over 80. We have an x, it's 32. We have a y to go with that x, it was 2. So we do some reduction here. Notice 16 will go into this. We know 5 times, we just got the 80 by going 5 times 16. 16 goes into this twice. So I'm going to change this 8 to 10 fifths and subtract this 2/5. Oh, we have the plus b, of course. That comes in. So I'm going to subtract the 2/5 over to solve for b. And so I have 10/5 minus 2/5. Of course, that's 8/5 is equal to b. So back to everything we needed. We had the shared point, we got the slope, and we got the equation of the line, because we know the equation of the line is the slope times x plus b, which we just found to be 8/5. So there is the line that is tangent to this fifth root curve when x is 32. Check. Math made simple.